Welcome and thank you all for joining us. I'm Talia Goldberg, partner at Bessemer Venture Partners, and we have been doing a series over the past few months with portfolio companies, with founders, with entrepreneurs and technical leaders, talking about building with AI, both automating existing workflows, learning about all different ways that teams have adopted and leveraged AI internally, and also those building AI native products. It's been one of the most interesting ways for me to learn personally, but also has had a ton of demand and interest from portfolio companies in the Bessemer community and externally. And so we're going to be investing more in ramping these up. And we are going to beta test our new name today for the series because AI R&D series is a little bit blasé and boring. So welcome to Research to Runtime. This is a series where we hope you'll learn, share feedback, and be able to ship great product with AI. With no further ado, I'll turn it over to Bhavik to get started.
Awesome. Yeah, thanks, Talia. Great to meet everyone. I'm an engineer turned investor here at Bessemer. And today we are joined by Samuel Colvin, the leader of Pydantic, Logfire, and David Soria Parra at Anthropic, one of the co-creators of MCP, to talk about building production scale AI agents. So just quickly diving in and setting the stage, Pydantic was originally released in 2017, but has been integral to AI agents in the agentic revolution over the last couple of years, and has largely been used to structure data coming in and out of LLMs. And then in 2023, we saw function calling that OpenAI released, and yet it was still hard to build these end-to-end agents. And then finally, late in 2024, David and Justin and their team at Anthropic released MCP, Model Context Protocol. That initiative has just seen an explosion, as we all know, over the last 6 to 12 months, and rapid adoption from companies large and small. So I'm excited for this conversation today. Samuel and David, thank you so much for joining us. And before we dive in, I wanted to talk a little bit about the inception story behind both Pydantic and MCP. Before these were full-blown projects, open source communities, these were just ideas in your head. And so maybe, Samuel, starting with you, how did Pydantic come to be, and how has it evolved over the last few years?
Pydantic started off way back in 2017 as a side project, stayed a side project. I started working on it full-time at the beginning of 2022, and then didn't start a company until 2023. So one of the reasons it's so widely used and so mature is that it wasn't one of these open source for VC backing companies or projects from the beginning. And so it started off just out of a frustration that type hints existed in Python, but didn't do anything at runtime. Could I do something to use them? And then actually, even after we'd started the company, while we were working on releasing Pydantic v2 and then building Logfire, thank goodness, other people went and picked up Pydantic and started using it in Gen AI. It's perhaps a unforgivable sin as a founder that I wasn't there desperately trying to shoehorn it into everything AI, but actually, thank goodness that went and happened without us, because it so happened that its characteristics, the lax stuff, the JSON schema support, happened to fit really well into Gen AI. And then actually, coincidentally, we announced Pydantic AI, our agent framework, I think the same week or earlier the same week as MCP came out. And when I first saw MCP, my immediate reaction was, oh, fuck, I wish I'd built that thing. It's such a cool idea. And then within a few weeks, I was like, thank goodness we didn't go and build something like that and then get gazumped by Anthropic a week later, because I think it would have been tough to build something in that space. So luckily that they came out around the same time, and they're very compatible. And so yeah, it's been great to work on Pydantic AI and also do some MCP stuff along the way.
That's neat. It's neat, especially that it started off as an independent project, then got picked up by the AI journey. Then what you built with Pydantic agents sits alongside MCP. It seems like you both have collaborated too over the last sort of many months, bringing those two together.
Yeah, absolutely. I'm somewhat involved in MCP. I try to help a bit. I'm not going to claim I'm a bit absent because I'm busy with other stuff, but yeah, definitely a fan and an occasional contributor.
Awesome. And I know, David, you've probably told this Inception story many times, but maybe for the group today, how did MCP come to be? How did you and Justin bring it to life?
Yeah, so MCP started roughly about a year ago, mostly at the idea of how both an idea of the type of project I worked on at the time, as well as just pure frustration at the time with dealing with the systems that existed. But it's really just, I think, a story of the frustration of having to copy things in and out of Claude Desktop and then Z Editor, which is one of my favorite editors. And the idea that I think there should be better ways of combining these type of things. And really what I wanted to do at roughly in August last year was just having a form of connector that can speak to both Z as well as Cloud Desktop that just integrates with like type of workflows that I deeply care about at work. And I brought this up with Justin, and Justin was quite fond of the idea. And together we tag teamed and built the SDKs, as well as like he built it into Cloud Desktop at the time. I mostly built it actually in the open, but not very seen by many people into Z at the time. And that's really how we built it. It's just for us initially, for our own use cases. But then, of course, we found that this has much broader appeal, and that we just truly believe that people should just be able to connect their workflows to the models and give the models agency over the environment that you are in that we cannot anticipate. And yeah, and like I'm on my side putting it together with Samuel and Pydantic. I'm a Python developer for the most part. And so, of course, the MCP is full of Pydantic usage. And I was lucky now that Samuel and the team reached out quite early and helped us because they're way better Python programmers than I am. And so they helped us with a lot of things along the way, as well as a lot of really good ideas. And so it's been, ever since quite early, actually, a quite good collaboration between the teams. And until today, Samuel and Marcelo from the Pydantic team are very active contributors to the Python SDK.
And with MCP, almost this like M by N combinatorial problem.
That's what protocols solve, right? Most protocols, or basically any protocol, solves technically just you have M clients or M peers and servers, and you're transforming this into an M plus N plus one type of problem with a commonality that everybody agrees on speaking. That's effectively what MCP is. It's a very boring specification that is backed by a set of hopefully less boring SDKs that people can use to actually build MCP servers, MCP clients. Yeah.
You came out with this protocol, and in retrospect, it's clear how much thought and effort you put into it. When you first came out, you have to go convince a bunch of clients, the cloud desktops, the Zeds, the cursors of the world, and a bunch of servers to start to adopt it. And there's this cold start problem. How did you go about that?
I think there are two ways you can do this. I think for things like Pydantic or open source projects that are more like framework, they can see a lot of adoption initially directly because it's directly useful to people. But protocols are just as strong as the ecosystem. So you have this inherent chicken egg problem. And so the way you deal with this is, I think a protocol like this must come from a big lab. If you build this, no matter how technically good another protocol can be, if it's not coming from a lab that has a certain pull in the industry, it will not go anywhere. And so there's a lot of incentives for the players in the market to work closely with Anthropic. And that's how you get clients. And once you have clients, you have servers. And now you get a flywheel going. And I think any lab could have done it. I think Anthropic, and maybe there's one other lab that would have been uniquely positioned to do this. Some are better positioned than others. I think we were pretty good positioned to do this. And I think that's a key part to that. And then the second part of that is you need to know how to do open source. And both Justin and I are very long, hardcore open source contributors. I've been a release manager for PHP. I've worked on Mercurial. I've done a lot of open source work, and you just need to know how to do this correctly and to do it correctly as a company, because that can be easily going wrong. And I think these things together is what makes a strong ecosystem in the end of the day. And so, yes, I think it's a lot of the market pull initially. And for that, like I just did it. Like I just built it for them. And they were like, yeah, why not? Like if some engineers in another company builds features for you, there's very little incentive to say no to that.
Yeah. And Samuel, was the growth journey at Pydantic or the adoption journey at Pydantic similar, or was it more gradual?
As David says, like we don't have quite the same level of network effect requirement that you have in a protocol. So I guess now Pydantic is ubiquitous. It's pretty impossible to install any AI stack without Pydantic being there. So we have a advantage in that we're now an incumbent in all of those regards. But to start with, you could find Pydantic useful in your own project, even if no one else in your company was using it. And then obviously Sebastian using Pydantic in Fast API in whatever, 2018, 2019, probably, although it didn't account even for a big percentage of downloads, especially early on, it was definitely the way that people found out about Pydantic. It was like the frameworks are the most loved or most questioned piece of technology, perhaps only behind databases. And so having a big framework that was pulling Pydantic helped us a lot early on. I honestly don't know enough about the exact lineage of how it started being used in function calling. Obviously, Jason Liu's talks, Pydantic is all you need and Pydantic is still all you need, had a big effect, but I don't think he was the first person. So I don't know whether that was inside one of the model companies or the early agent frameworks like LangChain, or how it happened, because as I say, we were heads down building something else at the time, weirdly.
We certainly have Pydantic peppered throughout the whole code base internally. So I don't know. I think this comes very naturally, right? Like at the time, people were picking up AI work in the big companies. I think Pydantic was already like very widely used because of fast API, because of just like the structured approach it brings. And then with the explosion of Python plus like some form of like structured things you want and validation you want, like Pydantic was a very obvious choice. And so I think it just, I don't know who was first, but I probably like all at the same time, I would assume, honestly, Samuel.
Yeah, I think you're probably right.
Yeah, Pydantic was peppered all over our code base at Covariant too. So I'm sure it's now universal in the industry. This has been a really helpful sort of 100-foot view into the growth journey. Maybe we can shift gears and just get a little more tactical. I know a lot of folks are joining us, some are really early in their journey with Pydantic and MCP. Some are really deep and already building. Maybe we can start with Pydantic. Where do you recommend people start with learning and thinking about it? Where have you seen the most useful applications or interesting experiences built on top of Pydantic?
Yeah. So I was going to say, with three things, the Pydantic stack is the Pydantic validation library, which is like infrastructural Python. We're like top 25, top 20 most downloaded Python packages. If you strip out all of the packages that are mostly installed as a dependency, you get to like requests, NumPy, maybe cryptography could be considered in that category, and Pydantic. So we're like probably top 5 if you consider what you might call like top level installation. So Pydantic is there. It's extremely widely used and mature. There's some stuff we want to do. We got another 3x performance improvement coming out of some Rust stuff we'll do hopefully later this year, but we're not going to go and add jazzy AI stuff to that. It does what it does, and it does it pretty well. Then we have Pydantic AI, which is our agent framework, which has, I think, the best support for MCP of any of the agent frameworks. We implement stuff like sampling, both on the client side and on the server side, which I don't think many of the clients or servers support. But sampling in particular, my talk yesterday, I was presenting at Google, was about sampling in MCP. And one of the reasons for that is sampling is, please excuse me being rude for a moment, David, a somewhat confusingly named part of MCP. It is not what you would generally think of in sampling if you're in observability. It's this idea that servers can effectively proxy their LLM calls back through the client. So you don't have to provision every server with its own LLM capabilities. Instead, you can, as I say, proxy the request back through the client. Very powerful feature. Great thing for us to demo because it's reasonably hard to do, and we can show the complex flow from client to LLM to server to client to LLM back to server and back to client in Logfire nicely. Yeah, and then the third bit is Pydantic Logfire, our observability platform. Yeah, does that sort of answer your question? And your question was where we get started, and I went off on a tangent. I think that the simplest place, from my point of view, the easiest place to get started right now, if you're interested in AI, is obviously if you're building in Python, you're probably building with Fast API. You're probably, if you're going to install any of the SDKs, you're already using Pydantic. To an extent, you don't really have a choice about that right now. If you want to get going with Pydantic AI, I think it is the best of the agent frameworks. I think it's not overbearing and trying to do too much for you. It's building the right primitives and letting you build the complex domain-specific stuff that is your IP and your logic. And what we see when people start using Pydantic AI is they then need observability, not because LLMs are unreliable, slow, and expensive, and Logfire comes pretty naturally at that point to instrument your whole application, but obviously particularly the AI bits.
Super helpful. There was a bunch in there that I want to unpack, sampling being one of them, and I know that there's a bunch of other features that we should talk about. One of the things you outlined, and maybe David, you can talk a bit about this, is just the broader structure of how tool calling and context gathering is starting to materialize through MCP and other systems in the AI agent space, which is you have a client, you have a host, your Claude Code desktop, your Zed, you have a client, and then you have a server. Maybe David, if you don't mind just quickly touching on the core underpinnings of MCP and the core design principles and what it's enabled.
Yeah, absolutely. In principle, MCP is a client-server architecture, which is quite deliberately because the client has a lot of more responsibilities. The client generally owns the LLM interactions fully for the most part, preferably fully. There are limitations to that, of course. And it pulls context from a set of servers. In that regard, it is very similar to the model that like language servers use, and it's very inspired by language server. I think if you look at language server and you look at MCPs, you will very quickly understand that these things look very similar in a different domain. And so servers are tasked to provide context in a set of semantic primitives that we define. And these primitives can be tools, which is probably the most widely used ones. So the model wants to call a tool, and then it gets forwarded to the MCP server, and the MCP server then does whatever it wants to do, commonly calling backend APIs. But you can do any form of shape of things you want to do. You can run custom code. You can just eval Python code if you wanted to. Anything goes. There's two other primitives that exist. One is resources, which is just like raw objects of text or bytes that can get pulled into the application to the client. And then the client is really free to do whatever it wants to. In most common cases, a client will just attach it as a file to the context window. But you can totally, and people do this, do RAG or other things over the input there as well. And then lastly, there's a thing called prompts, which is just basically a predefined templates that users on the client side can use to put into the context window to know, for example, how to use your MCP server nicely. And so the back to the architectural bit, the server is there to offer context via these three primitives. The client is there to navigate that as the owner of the LLM. And then most importantly in the architecture is that any type of complexity, we're trying to shift away from the server to the client in order to make client development as easy as possible, because you will have magnitudes of more of servers than clients. And so those are really the architectural bits, like some form of like semantic data layer plus client server architecture plus transport independence. That's quite important to us, or mostly quite important to me, to be fair. They're dividing options or opinions on the matter in the team potentially. And then, yeah, that's it. Like, again, so I think that's really it.
And if you were to compare that to a native API integration, which might be the alternative, or a lot of companies are calling them connectors or direct connectors.
So the question, what you mean by what native API, like API integration? Do you mean like native integrations between like a company's chat interface to their model and like a native connection to it? Or do you mean like more API first, like open API specs? I think those are two different discussions and they have very different answers.
Yeah, I'm almost thinking on Claude, there's some native connectors with Google Desktop and do those natively use MCP, or is that a separate?
Some of them don't, but that's historically. Technically, basically, as far as you can be concerned, every connector on Claude will use MCP in the future. That might not be true for other model providers, and we can talk about the trade-offs for why people choose one over the other. But for us, it will be true that we will use MCP everywhere internally.
Yeah, how do you think about those trade-offs?
Yeah, so the trade-offs I think is pretty simple, right? If you can make the engineering decision as a provider of that integration that it works well to make a very custom connection for this and maintain this custom connection, then you're probably at times better off because you have more flexibility, because you're basically having a person on the other side that you can define the semantics of this connection 100% depending on the exact needs of you. Where a protocol is always a generalization that inherently restricts what you are able to do fundamentally to that subset that you have chosen, or that I have chosen together with Justin eventually. And so while that subset is quite general, luckily, because the way LLMs work and the way like it's quite a unique thing that we have intelligence models that can use a very small subset of semantics to do quite big things. If you look at, for example, LSP has like 300, like 200 different messages types or whatever it might be. So these are way more complex because they're not built for intelligent systems on the other side. But again, even then you still run into problems where at times you might want to like build, for example, semantics around presenting UIs that you then can specify on both sides, which we cannot do easily in MCP. So it's a trade-off between engineering effort and the 10% gain you get compared to compared to something else. The equivalent example is like you can take a nice car on a track and you can get a good lap time. But if you spent the engineering effort to really tune it and spent the money that is disproportional for the effort, the effect you can get out of it, then you will have better lap times in the end of the day. And I think it's a very similar thing here.
David, can I ask you a kind of follow-up question to that? Because one of the things that I think is, I've seen quite a few people talking about this, and an obvious opportunity is basically your application ends up making a particular sequence of, sorry, I don't know what the hell my camera is doing. I apologize for that. But it's doing some weird thing with hand gestures. I don't know why it's doing that. I will try and stop it in a minute. I'll stop using my hands. It's in a particular, let's say you have some agent that goes and creates a pull request, right? And then does some follow-up things, applies some labels, merges a pull request once it's finished, applies some code review. Now, if you were doing that purely with GitHub's MCP, you would make 15 or 20 different MCP function calls through the MCP server. And once you've got that to work, you obviously don't want to either pay the money to go and do that every time. You don't want the latency, and you don't want the probability that it's going to go wrong. So there's obviously an opportunity to basically condense those 20 functions down into one, create pull request with label, and merge when passing. Yep. Is that something that you think MCP will start to have concepts of, or do you think there is like a space for middleware that does that stuff, or how do you think that problem is going to get solved?
I think it's a very good observation that we definitely share. I need to be careful what I'm saying. I do think that it's actually possible today already. If you think about like models can write code, and it's very easy to imagine that a model would go realizes what it has done over the set of inference and then condenses into code that is significantly better, and next time around uses that code again. And nothing prevents you from inside that code use MCP basically as an FFI interface. And that's just as possible. And you would still use the underlying function, so to speak, because the model at that point knows the exact sequence of return values. And we do actually have structured output in MCP now, so that the model can even do this in advance by knowing what type comes back from the MCP server. So this is possible. I do think it's actually solvable on the client side. I don't think necessarily MCP needs an abstraction around it. If anything, I could totally see MCP servers who do this for you by proxying other MCP servers, right? These things are always possible. But yes, I think it's a super good observation. And you do always want to look at the general, the model makes decisions based for you, whereas the decision is always the same, then you should probably not have the model do it, because that's inference, and inference is costly compared to a piece of code that can just compose this nicely together in a different way. If that makes sense?
Yeah, 100%. I think that from a very high level, the glorious potential of MCP is that it's what we all thought APIs could do back earlier in our careers. For me, that was 2014, when I was like, oh, if it's got an API, I can just go and build whatever I want. And of course, while that's theoretically possible, it was 100 man hours or whatever it might be to go and do that integration. And for most of us, that was just not possible in many cases, or we would do a few, but we didn't suddenly mean we could connect to everything that had an API. And now we have the potential that basically, if it's got an MCP server, I can trivially add it in, and now it just works. And it's the kind of thing that non-technical founders said to me in 2014. Now it is genuinely possible. Oh, they've got an API, so it just works. But obviously,
the reality is you just have an MCP server that generates new tools based on your interactions and just writes them to disk somehow, and next time just gives that to you. And it's completely possible to do. And they should just hook Pydantic AI into an MCP server, have the model probably has a reasonable good understanding of Pydantic AI. If not, you give it information and you say, okay, take these two calls that you have done now and just combine them into a new tool. And you can, one of the things that MCP is somewhat problematic with, but also equally amazing about, is this dynamic toolset. Toolsets can change, right? The MCP server in this session might present you 30 GitHub tools, but it might just generate you a new tool out of this. And the next time you see it is 5 tools, right? Because it optimized the flow. And you can totally do this. And you can do it even based on a user token because you're authenticated, right? These are all possibilities of things people have not played with. And I think there lies a lot of opportunities for people to just use Pydantic AI, for example, to make these optimizations, because they can use tools very simple in there and can combine them very simply.
Yeah, makes complete sense.
On that note, there's such a broad design space of things you might want to make the platform more extensible to do. It seems like right now you can already there's already dynamic tool search, discovery, service. You can already do that. But in the future, people might want to have MCP servers that pass back custom UIs to the client, or enable other sorts of experience client side or host side that just unlock new capabilities. I imagine that David and Samuel, like you guys have constantly faced a tug and like sort of a back and forth thinking through extensibility and security, or access and identity access control related to some of these themes. How do you think through those? And are there anything that you're mulling over at the moment in terms of things to include or not, or how to design something in...
I can answer a kind of adjacent question for us and let David answer it in the case of MCP. I think I am battle scarred from having built open source that is too opinionated and does too much stuff, and then having to maintain that, even once I've realized it was probably the wrong opinion. And so I think we're reasonably reticent within Pydantic AI not to go and we got this hammer of abstraction and everything looks like a nail and everything deserves an abstraction. I joke that I've spent most of my career...
More generics, Samuel?
Sorry?
More generics?
Yeah, exactly. I spent most of my career trying not to build an ORM, and I may at some point fail in my quest to not build an ORM, and we may end up with some basic one inside Pydantic AI for vector search. But it's very tempting to start building these things, and they seem cool, and they cover your use case, and you feel really good about that. I think when you've been maintaining open source stuff for, David, probably even longer than I, you realize that even if it took you an hour to write, it might take you months of maintenance over the next 10 years. And so do we really want to go and release that thing? And so we do quite a lot of like podcasts where I'll vibe code or generate some UI, show it to people in the podcast, get people's interest on that, and then use that as a way, or just basically put stuff up on GitHub, but not as a package, get people's feedback on it rather than going and smashing everything into the library. Because like I said, once you've got it in the library, the overhead of getting rid of it is much higher. I don't know, David, how you think about... It's harder in a protocol where you can't really be like, here's an experimental bit, because experimental means to be added soon, and someone will go use it and be furious if you then remove it again.
Yeah, that's one of the things you have as a protocol maintainer. Protocols are different in that regard. You're absolutely right. And I think, like for example, like Pydantic AI is very early, right? It has deprecation warnings already on certain things, and it's like completely expected. Like I used it very happily last week just for something private, and I was like, oh, deprecation warning, no problem. This is very early. It's completely moving target. This is great, right? Cloud Code takes the wheel and removes all the deprecations and moves to the new code, no problem. But for protocols, yes, you're absolutely right. That doesn't work. And so one of the things we're early on, or one of the things I think that you slowly learn is, or I learn as this new role as a protocol designer that I definitely have not chosen, but I'm someone now I'm presented with, is that adding is easy and removing is exceptionally hard, is just a default. And so what this means is that you need to be very careful, and you're looking a lot at composability of things rather than just opening up like one specific use case. You need to be really sure this is truthfully like long-term valuable, that is composable with other features, and that it like really opens up a complete new composability space rather than just adds up to this one or two specific use case. I think that's very important. The other part is you need to be very carefully looking into adoption in the ecosystem. And it's something we're paying a lot of attention to at the moment, because we are aware that clients have a hard time implementing it. And that's why not all, like most clients don't support the full specification. So there's no need for us to add even more features that people can't use. And so we just need to be very careful and help the client authors to, as much as possible, to catch up with the specification where it makes sense. But then in addition to that, we will have extensibility things. Like I've talked to a lot of people who have very successfully designed large systems that we all use on a day-to-day basis. I had the privilege to talk to Brendan Burns, who famously was one of the designers of Kubernetes, and had a bunch of other conversations with other people. And one of the common thread is just look at extensibility points that are somewhat optional that you can add. And we have these things. Some were hidden now, but there exists, and people will use this. And protocols is problematic to some degree because protocols try to be the common denominator. So extensibility is a bit of an anti-pattern. So it's a bit of a careful thing that you need to thread. And so we're just trying to do this very carefully and in somewhat uncharted territory. And there's constantly a balance to strike between moving fast in the AI space and being carefully and slow as a protocol designer. And it boils down to good taste. And only time will tell if in a year from now people think I have good taste or I have bad taste in the matter.
Yeah.
I think one of the things I see is like, I was an AI engineer and gave a talk on MCP. MCP is all you need, inspired obviously by Jason's talk. But I heard from a few people, there's a problem with MCP is that some of these clients don't support the things a service support. X has been out for 3 weeks and Cursor doesn't support it yet. And I was like, this is obviously people's first interaction with the protocol. Imagine back in the day when we were like, even now, is that the standard for the web is evolving and stuff takes 5 years to end up stable in all of the different browsers, longer in some cases. And
You're looking at the IETF, like OAuth 2.1 specification, which is literally just like best practices of OAuth 2.0 plus, and it's like it's a 5-year thing in the making, still a draft, right?
yeah, exactly. And people have this frustration, MCP, it's not good because the clients don't support it 3 weeks after the feature is released. And I think that kudos to all the people who are getting into coding as a result of AI, but some of them could do with a bit of looking back at how things were in the past and realizing how extraordinarily fast MCP is moving as a protocol, which probably increases the chance, all other things being equal, not a criticism of David, that we make mistakes because we go even faster because there's such a demand to go fast, right? That's inevitable. But also the bedrock, the like underlying conditions, the abilities of models are changing so fast that you can't afford to be slow about MCP and say we're going to have a 5-year consultation on introducing streamable HTTP, because that's just not going to be satisfactory for people.
Yeah. And then of course, like we always see this, right? We make mistakes. We all made plenty of mistakes, and it's just what it is.
Yeah. So there's the model itself, or the protocol itself, which is evolving. And then there's people's awareness and the actual implementation of the protocol, client and server side, that's also evolving. Maybe David and Samuel, as you guys think about bottlenecks or dark patterns or common mistakes, particularly on the server side, what sorts of tactical tips or dark patterns or mistakes do you tend to see?
I think that it highly depends what you're trying to do, but I think that boils down to tool descriptions, and it boils down to like basically organizing the system prompt, because tool descriptions go into the system prompt. And so it's a matter of having good descriptions, useful descriptions that fit to each other. So for example, a good tool could say, use this tool under these circumstances, avoid it under these other circumstances, and here's an alternative tool in this one scenario that you should actually use instead. That's a good tool description to some degree, because it gives our model clear action, when to do it, what to use. They should be somewhat broad. They should not be very minimal. It's actually the opposite to API design, where like REST APIs are very minimal. One endpoint does one thing at a time. It's not what you want with LLM tools, because they fit into the context window. They become exceptionally hard to distinguish for the model if you just take an open API spec and map it into MCP. You want to write very custom tools with great descriptions that interact with each other between the other tools. And then to be fair, you just want to eval it, right? You're dealing with a probabilistic system. For example, back to like shortcomings of the protocol, the prompts themselves are handled differently by the models, and you cannot give the model responses based on the model yet. So you just need to eval against the two models you care about the most. And then, of course, if you're building something more complex, you do want to rely on a framework like Pydantic AI that do a lot of the heavy lifting. If you want to have an agent loop and expose an MCP server, don't do that yourself. Use Pydantic AI and make it Samuel's problem that just speaks the most recent version of the protocol. Use things from people who have good taste, but then focus on your tool descriptions. And then lastly, if you, depending on your client on the other side, use the full protocol if you can. If you, for example, build a development tool for VS Code as an MCP server, like a Playwright server or something like that, you can use the full spec, because that's what VS Code supports. If you want to be compatible with everything, then you just need to use tools, because that's the only thing everyone will support. And these are the considerations that I think you need to have. But what I see for the most part is people write a function definition and like a 2-liner as a tool description. It's just bad, to be fair. I think that's really it. Samuel, anything on your end?
No, I was in preparing for this talk. I wanted to use Zed to demo the stuff I will hopefully demo in a minute. Discovered a problem with Zed this morning, was chatting to them on Slack, and they have been trying to get the fix. The fix is merged, but they're trying to get a release of Zed out. So I was just watching my Zed to see whether it would be like update available, but I think
Just
I will.
compile it nightly, man. Just compile it nightly.
It was merged 3 hours ago, so I need to. I'm on preview, so hopefully it'll come out a bit later. But I've got it to work anyway. But yeah, I don't think I have anything particularly clever to add there. I think there's a temptation to basically take an open API spec and be like, here we are. We've got a full thing. We've got here's 800 tools. It all works. That's
Yeah.
not gonna work. It's much more like building a UI in the sense that like you want to build the things that people want, and omitting some of the more advanced features in return for the common stuff working is worthwhile in the way that with an API you pay basically little or no overhead for that, so you may as well just make many small composable endpoints. So yeah,
Yeah, you might actually be better off having 3 tools like execute endpoint and like search endpoints, list endpoints, right? That might be a better MCP server because like you're not filling the system prompt with 500 tools and like using 100K of tokens before anything happens on the user side. So
at the risk of a plug, I think one of the great advantages we have in Logfire for building MCP is that we allow full SQL, and so we don't have to have loads of tools. We basically have execute SQL. Currently, we have a get schema function because resources aren't available on things like Z. So we just have a get schema function that it calls at the beginning, and then it can basically call run SQL. And I think we have 5 tools, and that allows incredibly complex use cases because basically you're using the run arbitrary SQL for everything.
But that's perfect. That's such a good example of just like back to composability. The models are pretty good at writing SQL. Like, why not make use of that? And of course, you need to be sure on your end that it doesn't do funky stuff. But I'm sure you have made sure that it's not doing funky stuff.
And structured outputs, it seems like it really enables this composability of MCP servers.
Yeah, absolutely. I think they're like, and having complex, reasonably complex parameters for functions instead of small functions with 2 parameters makes sense. Yeah, I think it's funny. We as a AI company are spending more time basically building a database that can run SQL, arbitrary SQL fast than we are doing stuff with AI, because the hard thing for us is basically being able to run your arbitrary SQL without knocking over some neighboring tenant's queries. But yeah, exactly.
Well, and so once you have an MCP server, or at least an initial MCP server, the next step is to eval it and to build a logging eval harness to start to iterate on it.
Can I ask a slightly different question just before we move on? I want David's opinion on something. I know that there's been a bit of disapproval of local MCP servers, as in theory, you'll have to run arbitrary code to use them. Everyone should have a remote MCP server. And I see the advantages of that, but that involves sorting out the auth stuff, which is still evolving. I think it's relatively settled in the protocol, but obviously we're waiting for the clients to support it. At the moment, we have an MCP server that runs locally and basically runs those SQL queries over our API. David, do you have an opinion on if you're building an MCP server? Should you start building a local standard IO one, and then once you've got it stable, move on to having it remote? Or do you think start with remote? Or if I was a bank, not bank's a bad example, if I'm a dev tools company, should I start building local, get confidence, and then host it, or start by hosting it?
I think everyone should build it locally first. I think the reason is I think a big part of what made the MCP useful to people and exciting for people is that I want to do something, I want to teach the model something, I have something running is usually 15 minutes, 30 minutes, maybe an hour, if a worst case scenario, when it's local, and it's a very good experience if you're a developer and you understand what you're doing. I'm, to be fair, somewhat surprised by the lack of understanding of how standard in and standard out works on some developers, but besides that point, I think it's a very good experience. And I would always start local because it makes it very easy to debug if you know what you're doing. Like, you just log to a file or you put T in between or something like that, right? There's tons of opportunities you can do to just get the raw stream, and it's very easy to debug. So I do think local MCP servers are super worthwhile. I do even think that they're even great for developers for their day-to-day use if they're not just building it. Like like a Pydantic Logfire like MCP server locally seems to be completely reasonable to me, particularly if it's in a Docker or container or something packaged up where you can reasonably assume that most developers will have Docker installed. And so I think that's completely great then. And then you move it over, because streamable HTTP is tricky, and there's a lot of tricky bits to authentication to streamable HTTP, and you don't want to deal with this before you get your endorphin kick of like your dopamine kick of like, I built something, right? That's cool. I think you want that first, and then you're willing to go through the pain that is running this on the internet.
Yeah, I agree entirely.
And then you just swipe the credit card at Cloudflare or Vercel, and they do that for you.
Yeah, absolutely. And I think, yeah, I think the other thing is that as you, even in a company of Pydantic size with 20 people, getting a new service deployed and having buy-in from the team that we're actually going to maintain that, is that all set up with all of the right checks? Is where, which project is it being like logged into with Logfire, et cetera, et cetera. Like even at our scale, that is difficult. If you get to Anthropic scale, it gets harder. If you're a bank, like deploying a new service, or your big, larger company, it gets harder and harder. Whereas releasing a new, basically what is effectively an open source library is always much easier, which is another
Right, and
reason.
for developers, they do have usually a mechanism to like already get like internal packages, and that's somewhat easier and somewhat manageable via like hashes and so on. And as long as they know it comes from internal to the packagement system, and then like it's just an NPX away from you, and that seems to be super easy to do. Very early at Anthropic, we had in our code base that everyone most of the time has checked out, just like an MCP server that is pre-configured in your Z, and it's just like you start, and it basically becomes like adding like a tool annotation to a function in a Python file, and that's how you add new things for yourself. And that was quite easy and quite cool to do.
Yeah, we
That's a
have
cool way
we
to share things
inside the
across.
Logfire code base, we have I think it's not Z because I'm still in the process of persuading all of my team to use Z, but there is a cursor file that has the Logfire MCP server set up. So when people basically start using
Yeah.
a cursor, et cetera, they basically, and when they go and start basically trying to fix a bug, it can go and connect to Logfire and get the data about what's actually wrong in production or in staging without having to even think about any setup. You don't know what your agent's doing. Like maybe it's looking at Logfire, maybe it's reading files. It seems to fix it better.
So Samuel, you've been telling us about Logfire. I'm so curious to see the demo.
Yeah, happy to share the demo. As with all demos, this one may or may not work. I was just trying to run it just now and I couldn't get it to fail. That's which I needed to show the problem. So we have numerous different sorts. But yeah, I'm going to share my screen. Hopefully you can see that. I'll put you guys over there.
And
I'll give
you
it.
guys host a remote MCP server?
No, we don't. It's local. So the one I'm going to run now is local. Other advantages, you can go and edit it if you want. I know some of our customers are like tweaking it to run it slightly differently, but I'm actually running the app locally because I've introduced a bug into it. This is our Connect 4 demo that we use to demonstrate Logfire. And so we can use it to play Connect 4 against an AI. And as I say, for the most part, they'll be fairly poor at it. We actually have a local Minimax model someone wrote in TypeScript, which is extremely good at playing and is actually quite fun to play against. But here is GPT-4o. But when it comes back, if I go in this column, oh, I'm getting a 500 error. And I could go and look through Logfire and try and work out where that error is coming from. I'm not going to show you the error here in particular, but instead I'm going to just go in and basically ask Z if it can solve that error. So I have just set up in Z, in my Z local settings, Logfire MCP, and I have an environment variable set so it can query Logfire. If I come over here to, I'm just going to copy paste the query that I was running. So I'm just going to start a new thread and I'll say, I'm getting an error making a move. When I use the last column, use Logfire to find out what's wrong. And if we come over here, we should be able to see in Z settings that we have one MCP server registered called Logfire, and it has these 5 tools available. And we can see we have, I hope, sufficiently extensive descriptions for them, but that should be enough for the LLM to be able to go and try and work out what's going wrong. And so if we run that and the gods of demos are with us, it'll do a bunch of thinking and you'll see it immediately calling the SQL reference tool that I was talking about, which if I can pump out what it returns a whole bunch of information about the schema and how to query it and the example queries, I think, and stuff like that. Where's that? If I close that, it's now running. So it's running some arbitrary SQL here. And in fact, it's already found the issue. So it ran some arbitrary SQL, got back a bunch of results. And in fact, it's printed out here a URL I can go to look at the error in Logfire. So if I go to that and the gods are with us, it should, yeah, so it's immediately gone and found the error. And so it's now that it's got the actual exception from Logfire, it's able to then go and start looking through the code to work out exactly what's wrong. And it has proposed to change or hasn't proposed to change. Yeah, so it's correctly found that basically what I had actually done was I had added this constraint to the SQL to say I had to put it in column 0 to 6 instead of 1 to 7. I don't think it got quite the right fix, but hopefully you get the idea of the power of MCP and effectively allowing the AI, whether it be Z or Cursor. I could run exactly the same thing if I ran ran Claude, and it would go off and basically do exactly the same thing. It will also connect to the same MCP server and go and look up the solution. Yeah, but it basically, in this case, gives your coding agent of choice visibility into what's actually happening as your application is running, rather than just being able to see the code.
And so now you treat your MCP server as like a first-party product for Pydantic. It's not just a wrapper around APIs that you've exposed. Like it is.
So it is a wrapper around APIs that we've exposed because we basically have one API, which is write SQL. And so we've actually coarsened that slightly. We've actually gone, that is, I think, actually doing the wrong thing. Let me actually just quickly check. Called MCP list, I think I can use to get a list of MCP servers. Okay, so that one is registered. And I think Claude Code was deciding not to call it for some reason. But yeah, well, in this case, we have an unfair advantage as a company because we have the SQL interface. That is a very powerful way of of building stuff like this. If you didn't have that, then you need to go and take your API and start building, as David said, particular tools, which are the combination of multiple different API calls to give the agent a chance of solving it. Does that make sense?
No, that makes sense. What an exciting time to be a developer.
Yeah, I'll just say on this particular one, like I as someone who loves writing code, am definitely not like universally pro a world in which AIs are better at it than me, and there's no commercial reason for me to write code. But I am not upset about the idea that I live in a world where where an AI can go and trawl through masses of logs or traces and work out why something is going wrong and give me a summary of what the issue is. So I think this is like one example where AI should be great, and the mixture of MCP, SQL, and OpenTelemetry gives us a great opportunity for like innovation in this space, right? And the other nice thing about our MCP server being open source, we can go and innovate and iterate with the open source community on how to do that. Like, what is the best way to display traces to an LLM in ASCII? Open question. Should it just be a pile of JSON? Should it be YAML? Should it be some kind of indented XML? Good question. But we can go and experiment with that and run the evals and stuff and do that in the open because MCP lets us build that thing locally.
And to go to close the loop fully, I think it's super interesting because you have an open MCP server. You can also take that MCP server, put it back into Pydantic AI as a server, and now build your own agent loop that you can either use in the way you want, or you can expose it as an MCP server to your client again. So you can even add arbitrary intelligence on top of that in a very composable way. And I think that's what everybody is currently trying to do, is just building these building blocks. And I think Pydantic AI has done a fantastic job on the framework side of things. I think obviously on the protocol side of things, I think we've done quite a good job so far. And so I think there's a lot of things that you can just add together using these type of things.
Awesome.
Someone's asked a question, Sid's asked a question about communicating directly with tool calls. I can, when you say communicating directly with tool calls, assuming if they're running within a single application, if you're at a scale where that's happened, where it can all go on within the same Python process, direct tool calls are great and they work really well. But at some point you get to a situation where you don't want to do that. So for example, if you want to go and introduce, extended the demo I gave yesterday to give my client access to all of GitHub with a one-line addition and setting an API token. If I had to go and integrate with the GitHub API, that would have been weeks of work. So that is one definite case where it's an enormous win over go implement it yourself. And then if you have bigger systems where you end up needing servers hosted separately or tools that are hosted separately from the agents that are calling them, then MCP is by far the easiest way of doing it. Yeah. I hope that maybe David, you have something better.
Yeah, it's exactly that, right? If you're in a closed system that you control end to end, don't bother with MCP. Just write your tools, write your Python functions. But the moment you want the extensibility because you want the flexibility or because it makes sense in your product, then definitely do that. If you Like if you build an agent that does debugging and you want to try it against Sentry and combine it with Logfire or any other combination of providers like that, that's where you want to use MCP. Or if you want to expose it to an existing client like VS Code, like Cloud Desktop, whatever, then it's great. But if you don't, if you just write an agent for yourself that does your thing and you write it all by yourself, then you just use no MCP. And that's what I do too. I wrote an agent the other day and very little thing for my EVE Online game stuff, and that was all Pydantic AI and had zero MCP in it because I controlled the whole thing end to end.
One last question for myself, and then I just want to be respectful of time, but both of your time, I know it's late British time. There's a rumor floating around that GPT-5 and some of the newer models will start to support MCP natively. And I don't know if that means they will post-train to support specific protocol serialization or what exactly that means. But if we start to see that support natively at the model layer, you'd imagine that's even more pull for using protocols like MCP. Is that a trend that Samuel and David, you both are seeing? Is that something that people that are building the space should be aware of?
I can give the answer. Go ahead, David.
Go ahead, Samuel. You probably have the more nuanced answer than I have.
I can maybe be more honest about other model providers than you can, but David understands the inner workings of the big providers better than I do, but it's not native in this. It's just tool calling, right? Sure, there's some wrapper on the outside of the model that takes care of calling that tool via fundamentally using the MCP SDK or making a direct network call or whatever it might be. But it's just tool calling. I don't know if there's any particular, maybe the stuff around scopes where you could post-train, but it doesn't for me. It's a feature on the outside. It's not within the model itself. So I think it's a bit hype, but David, do you think?
I agree somewhat. I'd be curious about the specific. I can see a world where MCP itself have a certain set of functions, like list all my tools and basically go through the list of tools. I could see models being deliberately trained to be very good at that specific case so that tools do not need to sit in the system prompt in advance, for example. There would be potential benefits for that. That's where I see it. But I don't, where models might be able to say, I want a specific resource and has a notion of resources. I can see that too. I'm not sure what these specifics would look like. You would have to see it. But that would be as far as I can envision in this moment, and that's someone that has basically no inner workings, view into the inner workings of research at Anthropic. So I have no clue how these things would actually work. But yeah, so it's just me lucky guessing.
No, super helpful though, guys. This has been super insightful.
There's one more question, by the way.
Yes,
okay,
David,
yeah, maybe we'll take that and wrap.
Where do you see MCP maturing in the future, enforcing secret masking to the LLM or controlling data segregation, multi-tenant, and no personal agenda? From Francois, I do see MCP maturing eventually to a point that it has a lot of these type of things to some degree. But I think back to Samuel's point originally, it's very early. The protocol is not even a year old as it is released. And so that is, in AI terms, very long, in a protocol development stage, exceptionally young. And so I do think we will get there, but we need to get there carefully, and we need to get there in a way that we are confident that these are the right primitives without having a protocol that has 1,000 different options that are effectively not used. And so that's the tricky part to balance. But I do think that security is a big focus and will be a big focus. The same with authorization. You will see focuses around authorization from machine to machine. At the moment, it's very human to machine. And I think so. Security, authorization, authentication, I think are big topics that I think we will see maturing out of enterprise needs very early. And then there's maturing in other aspects like agent to agent communication and other parts who will come as well. But they will come at the right time. And that's really the tricky part here without losing the client implementers and by building something that then server implementers can inherently do. And if you are in a pure enterprise context, in a pure, very controlled environment, you can already extend the protocol to your needs as you wish. Something people must not forget is that the protocol currently is very deliberately built such a way that it's extensible. That might not be true for the SDKs potentially at all times, but it's certainly true for the protocol. you can add new messages to it, basically, if you convince all the clients you care about and all the servers you care about to use them.
Just thought I would add, if you would humor me with 2 seconds, I just add one more thing that I meant to show when I was presenting. I thought it's interesting on the MCP side. So you can see I slightly tweaked the prompts and reran Claude code here. And what you can see is I asked it a question, it came up with its like to-dos, and then it immediately has within the context from the SQL, from the resource, our like SQL guide. So it doesn't have to go make a tool call, that's just smashed into the context. Whereas Z, that doesn't yet support resources, immediately makes a tool call to a tool that happens to return the same thing and gets it into the context that way. But you like,
Which then uses more tokens, by the way, right? Because you're doing a tool call.
yeah. And that's why resources are a nice feature. I'm sure the Z guys will add support for resources soon, particularly if I carry on doing podcasts and pointing out they don't have it yet. But
If not, I have to go
awesome.
back and find the source code and do more hacking on it.
They'll have it supported soon.
Yeah.
Awesome. Alrighty, Samuel, David, this has been lovely. Thank you both for sharing your time with us. And thank you guys for all the great contributions to the community.
No problem. Thanks so much for having us. Pleasure.